A pleasant good afternoon to every one of you. It's my immense pleasure to welcome every one of you to this open public vivos of my PhD research scholar of Bharatiyar University. Now I am happy to introduce the examiners of this PhD public vivos, the university nominee and the external examiner to this August forum.
Madam,
Bharatiyar University nominee is Dr. E. Vadivel, Assistant
madam,
Professor.
madam,
Sir?
please unmute your video, madam, please. Okay, madam.
Okay, sir. Bharatiyar University nominee is Dr. E. Vadivel, Assistant Professor, Department of Information Technology, Bharatiyar University, Coimbatore. His research interests are computer networks, information security, cyber security, pervasive computing, mobile ad hoc networks, wireless sensor networks, data mining, digital image and signal processing. SAC has published around 95 papers, of which 5 of them are book chapters. SAC has produced 6 PhD scholars so far, and 6 more candidates are under his guidance. SAC has received a sponsor for his minor project titled A Protocol for Reliable Routing in Mobile Ad Hoc from UGC in February 2011 for an amount of rupees 1,20,000, and he has successfully completed in February 2013. SAC has also received a sponsor for rupees 1 lakh for an orientation on cyber security and its impact in October 2021. For this sponsor, he has got from RUSA, and he has conducted that orientation on 28/12/2020. Sir has chaired the technical sessions, and he is an invited speaker for many national and international conferences and seminars too. Sir has organized 2 national seminars and a certificate course. With these credentials, I am honored to welcome you, sir. Welcome, sir.
Thank you, madam. Thank you.
And the external examiner is Dr. Satish Chandram, Professor, JP Institute of Information Technology, Noida. Sir obtained his BTech and MTech in Computer Science from Birla Institute of Technology, Ranchi. He received his PhD from JP University, Himachal Pradesh in 2010. At present, Dr. Satish is working as a professor in the Department of Computer Science and IT at JP Institute of Information Technology, Noida. Sir has 20 years of teaching experience and 11 years of research experience. Sir has supervised 5 PhD scholars. His research interest areas are artificial intelligence, machine learning, design and analysis of algorithms, cloud and network security. He has been organizing many national and international conferences, and he is the organizer for, he has given some invited speaks also. He is also an editorial board of several international journals. At present, he has focused his research in the application of deep learning approaches in medical image analysis. He is a member of institutional committees for doctorate progress assessment, NBA, and NAC Innovation Cell, Sustainability Development, etc. And with these credentials, I am elated to welcome you, sir.
Thank you. Thank you, madam.
So we have such a great personalities as the external examiners for this public Viva. It is my prime duty to welcome my beloved principals who have graced this meeting through online mode. Dr. T. Senthamil Selvi ma'am, Raja Sarfoji Government College, Tanjavur, and my parent institution, and Dr. K. Gunasekharan sir, Government Arts and Science College, Kuttalam, Mayiladuthurai. This is my deputed workplace by the Tamil Nadu government. I heartily welcome Dr. K. Mohan Kumar sir, the head of the Department of Computer Science, the heads of other departments, my fellow colleagues, and colleagues from Raja Sarboji College as well as from Kuttalam College. I do welcome the pillars of the society, the research scholars, PG and UG students, for whom this forum will be an inspiring one. Now, I take this moment to introduce my PhD candidate and her research work. Yes, Manimoli is a part-time PhD candidate of Bharatiyar University from January 2014. The candidate received MCA and MPhil from Bharatidasan University. The research scholar is currently working as an assistant professor in the Department of Computer Science and Applications in Periyar Maniam University, Vallam, Tanjavur. She has 5 years of teaching experience and 5 years of programming experience. Uh, During her tenure, she has developed a lot of she has automated some projects also. Um, while she was a student of Holy Cross College in Trichy, she completed the project the timetable management system, which is used for staff and departmental. While she was working at Bond Sectors College, Tanjavur, she automated online voting system, online feedback management system, online SMS management system for students, student mark details. While she is working, present she is working in Periyar University. There also she has developed some packages like online entrance examination, online application form, and SMS integration with the student details. So she has wide knowledge in developing algorithms and some in IT side also. The candidate has published 7 papers in the peer-reviewed national and international journals and conferences with regard to his research work. She has researched on a mobile ad hoc network. She has proposed a new and novel architecture which allows the mobile users to roam freely in the different IP networks or MANETs. She has developed and designed algorithms to provide intermobility as well as interoperability between different IP MANETs. The highlight of her work is the MANET or network can be established where no infrastructure is predefined or pre-established. So that is the main thing. Her research of literature study covers more than 100 papers, 100 research articles, survey papers she has done. And she has identified the research gap between the intermobility architecture between IPv6 mobile node to roam freely into IPv4 MANET, as well as for the IPv4 mobile users to roam freely into IPv6 MANETs. And also from the literature study, it is an observed fact that there is no existing research work to provide intermobility or interoperability between different IP MANETs. So by this way, the candidate has progressed her research work by narrow downing to design a new architecture for providing intermobility and interoperability between 2 different versions, IPv4 MANETs and IPv6 MANETs. She has done the simulation in NS2, and she has covered all the necessary metrics also for her performance study. So the candidate has completed her research work in 2019 itself. Okay. So related to her PhD research works, the candidate has published 7 papers. One is published as book chapter in Scopus Indexed Springer series. 2 are published in IEEE. 2 are published in UGC journal. Her research works have 5 citations so far. So with all these credentials, I wish the candidate to successfully present her thesis and defend her work with the queries raised by the participants. I once again extend my warm welcome to everyone. Okay. So now I invite the external examiner, Dr. Satish Sandra, to take over the session.
Okay, madam. Madam, please record the session, madam. Madam?
Sir?
Please record your session.
It's already in record mode, sir.
Record, okay.
Okay.
Hello, sir. Good morning. Very well, sir.
Very good morning, sir. Good afternoon.
Welcome, bro, sir. I'm sorry. Good afternoon. Okay, thank you.
Good afternoon, everybody. Uh, I think that we should start the presentation
Yes, sir. Yes, sir.
now. Yeah. So over to Miss S. Manimoji.
Okay.
Please start your presentation, ma'am.
Yes, sir. Thank you, sir.
Yeah.
Good afternoon to everyone. I'm very happy to welcome you all for my biggest Viva examination. We have designed an intermobility architecture for IPv6 mobile node in IPv4 MANET and IPv4 mobile node IPv6 MANET. So, we entitled our thesis as a seamless IPv6 IPv4 intermobility architecture in IPv4 and IPv6 MANETs. My presentation is organized in following manner. In the introduction section consists of research flow, MANET, internet protocols, transition mechanism, motivation, aim, and objectives of my research work. Today, the network world can establish the communication using either wired network or wireless network. Many researchers are focused to propose different architecture for addressing in IPv4 and IPv6 networks and MANETs. My research is narrowed down to provide an intermobility architecture between IPv4 and IPv6 in MANETs. MANET is one of the most important application areas in ad hoc network because of its infrastructural system and to provide communication to the mobile nodes and dynamic in nature. MANET, there are various applications used to establish the communication among mobile nodes in ad hoc network such as military battlefield, education scenarios, personal area network, Bluetooth, commercial and industrial scenarios, especially in the area in the emergency situations such as disaster, earthquake, cyclone, etc. In order to establish the communication among mobile nodes, the mobile nodes used IP address for its communication. The address in the MANET is allocated by using either IPv4 or IPv6. Both protocols users are existing in the network. The chart shows that the usage of IPv6 is increased when compared to IPv4. Both protocols have different features, such as in IPv4, the addressing 32-bit, it supports 32-bit address size and it supports 2 power 32 number of addresses, whereas it in IPv6 in address size is 128-bit and the address it supports 2 power 128 number of addresses. According to the address configuration, IPv4 uses manual allocation and automatic allocation using dynamic host configuration protocol, whereas it in IPv6, stateless or stateful auto-configuration mechanisms are implemented. According to the routing, in IPv4, unicast, broadcast, and multicasting are to be implemented. In IPv6, unicast, multicast, and anycast will be supported. According to the header format, IPv4 consists of 17 fields, whereas in IPv6 consists of 8 fields only. In the mobility, IPv4, the triangle routing between home agent, foreign agent, and corresponding node is be enabled in the IPv4. In IPv6, there is no such triangular routing problem. According to the security, IPv4, IP security is an optional field, whereas in IPv6, it is an inbuilt security. The address in the IPv4, the address in the IP, the address, there is a need for the conversation between the transition from one mobile node to another mobile node. So that there are various transition mechanisms are to be proposed. The important three transition mechanisms are standardized by the internet community. They are dual stack, tunneling, and network translation. In a dual stack, it is running both IPv4 and IPv6 on the same device. The limitation is that latencies be occurred in the dual stack. In the tunneling, the transporting of IPv6 traffic through IPv4 network transparency. In the limitation, tunnels requires IPv6 static routing. The network address translation, it maps IPv4 temporary addresses with IPv6 addresses and provide communications with IPv4 users. The limitation is that no mapping of IPv6 addresses with IPv4 addresses. Various transition architectures have been proposed to solve the roaming problems between IPv4 and IPv6 networks. However, the existing mobility architecture do not provide the solution to configure address while roaming in different IP manets and provide intermobility between different IP manets. And these challenges have motivated former researchers to propose a new architecture for IPv6 in IPv4 intermobility architecture between IPv4 and IPv6 MANETs. The aim of the research is to permit roaming of IPv4, IPv6 in IPv4 MANET and roaming of IPv4 mobile node in IPv6 MANET and provide the address configuration from other versions of the internet as well as provide the communications while roaming in different MANETs. Focusing on the above issues and challenges, the objectives of framing us to study the issues, limitations of IPv4 addressing, IPv6 addressing, mobility protocol, and transition mechanisms to design an intermobility for IPv6 in IPv4 MANET and IPv4 in IPv6 MANET, and to develop various interfaces to achieve the intermobility architecture, and then to study the performance of the communication while roaming in different MANETs. Our literature studies, which covers three important areas such as IP address configuration mechanism, mobility management protocol, transition architecture. The research factors are what are the IP address configuration mechanisms in IPv4 and IPv6. Research factor 2 is what are the mobility management protocols in IPv4 and IPv6. What are the transition mechanisms proposed in IP mobile internet protocols, and the research factor 4 is what are the metrics limitations in addressing mobility and transition architecture in IPv4 and IPv6. The first literature study focused to study the addressing configuration in IPv4 and IPv6. IPv4 address configuration mechanisms in IPv4 network, IPv4 MANET, IPv6 network, and IPv6 MANET. IPv4 addressing in IPv4 networks. NASA et al. In the year 2008 proposed one-step addressing. It repeats message process until it receives. It's only suited for stateful approach. Uttam Kosh et al. In the
Madam,
year 2000. Yes,
please
yes,
skip
sir.
the literature reviews, madam.
Sir?
Skip the literature studies.
Okay, sir. Okay, sir. Okay. So this is one of my research papers, IPv4 addressing in IPv6 networks. In this architecture, the researchers introduced IP-enabled gateway translator in IPv6 network in order to provide the communication of IPv4 mobile node in IPv6 network. The limitation is that it is not suitable for IPv4 addressing in IPv6 managed. So this is a second literature. This is a second literature part which covers IPv6 address configuration mechanisms in IPv6 network, IPv6 MANET, IPv4 networks, and IPv4 MANET. This is my second paper, IPv6 addressing in IPv4 network. In this architecture, the researchers proposed IPv6 enabled gateway translator is introduced in order to permit IPv6 mobile node roam into IPv4 network and get services. The limitation is that it is not suitable for IPv6 addressing in IPv4 MANET. So from this address configuration literature studies, we observed that IPv6 mobile node roaming is not considered in IPv4 MANET. IPv4 mobile node roaming is not considered in IPv6 MANET, and no work for IPv6 address configuration in IPv4 MANET, and no work for IPv4 address configuration in IPv6 MANET. So our research is focused to need of IPv6 addressing in IPv4 MANET, need of IPv4 addressing in IPv6 MANET. So the second literature study is focused to study the mobility management protocols under IPv4 mobility and IPv6 mobility. From this mobility in MANET, we observed that different mobility protocols using mobile internet protocol version 4 and mobile internet protocol version 6. IPv4 mobility within only IPv4 networks and IPv4 mobility within IPv4 only MANETs, as well as IPv6 mobility within IPv6 only networks, IPv6 mobility within IPv6 only networks. So our research is focused to IPv6 nodes mobility into IPv4 MANET and get services, as well as IPv4 mobile nodes mobility into IPv6 MANET and to get services. So this is a third literature area, transition mechanisms. So the literature is focused, the literature is we carried out on transition mechanisms for IPv6 and IP addressing. So the research focused to study the transition mechanisms. So this is a literature study for transition mechanisms for it. This is a literature study carried on mobile IPv6 and mobile IPv4 addressing. From this literature study, we observed that different transition mechanisms in IPv4 and IPv6 networks. IPv4 transition mechanisms in IPv4 network, V6 networks, IPv6 transition mechanisms in IPv4 networks, mobile IPv4 transition mechanisms in mobile IPv6 networks, mobile IPv6 transition mechanisms in mobile IPv4 networks. So our research is focused to IPv4 translation and mapping from IPv6 to V4 MANET and to get services, as well as IPv6 translation and mapping from IPv4 to IPv6 MANET and get services. So the research contributions in the literature to be carried in the three aspects: IP address configuration mechanisms. And the findings are IPv6 mobile node roaming is not considered in IPv4 MANET and vice versa. As well as the research gap is the need of IPv6 addressing in IPv4 MANET and IPv4 addressing in IPv6 MANET. In the mobility management protocols, different mobility protocols using mobile internet protocol version 4 and mobile internet protocol version 6 need IPv6 mobile node mobility into IPv4 MANET and to get service and vice versa. According to transition mechanisms, different transition mechanisms in IPv4 and IPv6 networks, transition mechanisms between mobile IPv4 and mobile IPv6. So the research gap was all need transition mechanisms from IPv6 into IPv4 MANET and to get services, as well as need transition mechanisms from IPv4 into IPv6 MANET and to get services. Based on the literature study and observation in the intermobility architecture between IPv4 and IPv6 mobile node in MANET is proposed. It will be achieved by the two contributions such as IPv6 mobility architecture in IPv4 MANET, IPv4 mobility in IPv6 MANET. The contributions are: let us consider that the pink highlighted networks are IPv4 network and IPv4 MANET. The yellow highlighted networks are IPv6 network and IPv6 MANET. We couldn't predict any mobile node movement from one network to another network. So there is a necessity to establish the communication among different versions of the mobile nodes. So in order to achieve this, the first contribution is to solve the IPv6 mobility architecture in IPv4 MANET. The contribution one is the IPv6 mobility architecture in IPv4 MANET. To achieve this, architecture, the nine functionalities are to be executed: leader node election, tree construction procedure, neighbor node response, addressing architecture, enabled gateway translator, binding registration, COA registration, router discovery, and redirection of the packet. Let us consider that an IPv6 mobile node A with 128-bit addresses, which is either in the IPv6 network or IPv6 MANET. Let IPv4 node as a B1, which is a leader node in the IPv4 MANET. When the IPv6 mobile node A roams into IPv4 MANET, it is to be identified with 32-bit. For this, V4 enabled gateway translator is installed to all the neighbor nodes through B1. This is the architecture for IPv6 mobile node in IPv4 MANET. Let us consider that the IPv6 mobile node called A roams from IPv6 network into IPv4 MANET. It is called it as A dash. In the IPv4 MANET, all the mobile nodes are communicated through the leader node called B1. For that communication, the B64 gateway translator is installed automatically through the B1 in order to find the neighboring nodes. Then the newly generated address is used to configure IPv6 address in IPv4 MANET. Leader node selection. In this IPv4 MANET initiate the communication. B1 enter into the MANET and check if B1 is out of the network range. If B1 is within a network, then it will be a leader node. If not, the leader node which has joined next to the B1 in the network, it will become a next leader node. For establishing the communication in the MANET, the tree construction procedure in MANET be executed. Here, in this tree construction procedure, the initial node is called as a leader node and the remaining nodes are called as a neighbor nodes. All the neighbor nodes in the MANET need not to participate in the communication. The leader node waiting for the neighbor node's request which needs communication. Based on the request, the tree construction procedure is to be executed. In the tree construction procedure, the leader node is called as X, the join node are called D, C, G, E, and F. The nodes willing to join are marked as M, N, O, and L. The nodes which are not willing to participate are H, I, J, and K. In this tree construction, the leader node is act as a router which is used to route the packets among to its neighbor node. The neighbor nodes are appended at the end of the leader node. It is created the tree structure and it creates cluster group. Each cluster heads act as a group head and other nodes acted as a cluster member. For the MANET communication, the clusters are arranged based on one hop neighbor. And this is the mobile node 64 tree construction procedure for MANET. In this construction procedure, the IPv6 mobile node enter into the MANET. Then the IPv6 mobile node sends construction request to the leader node B1. It checks whether IPv6 mobile node receives a response within a time. If it is receives the response time within a time, A dash receives addresses from the address pool. If not, IPv6 mobile node again sends the construction request. The selected address will be checked by the DAD. In the check the DAD status, DAD is nothing but duplicate address detection. If DAD replace exists, then IPv6 mobile node selects another address. Otherwise, A dash waits for selecting another address. If IPv6 mobile node sends acknowledgement to the leader node regarding to the newly selected address, IPv6 mobile node sends and receives the message using the new address. Mobile node 64 MANET neighbor node response. In this procedure, the IPv6 mobile node sends construction response request to the leader node B1 for joining into the tree construction. B1 received a request from IPv6 mobile node and then B1 checks whether it is a neighbor node or not. If IPv6 mobile node is within a region, then B1 checks its status to accommodate one more child as a neighbor node. Otherwise, it's discarded a node. If the new node receives construction response acknowledgement within a time, then the child table will be updated. IPv6 addressing architecture in IPv4 manner it is one of the most important functionality procedures in this intermediate architecture. Here, the IPv6 mobile node receives new IPv4 address from B1 by sending request solicitation message. B1 consists of 32-bit address in a decimal format. The first 16-bit is assigned as the format prefix that has not been reserved by other types of IPv6 address. So, we used to initiate the format prefixes 1001 in order to identify the packet from IPv4 manner. The 32-bit for IPv6 address is assigned into the 17th to 48-bit position of the IPv6 address, which is converted into hexadecimal format, is used to identify the node is in the particular IPv4 network. Then the 49 to 64-bit position is assigned at the 0. The last 64-bit using the MAC address, the IPv6 mobile node generates the 64-bit address in the least significant part. V6 enabled gateway translator. The V6 enabled gateway translator is installed automatically to all the mobile nodes in MANET bounded region. The V6 enabled gateway table stores MAC address on its home agent version 6. If A dash wants to communicate with IPv4 MANET, the V64 gateway is generated IPv4 address for A dash. Using this address, A dash can communicate with the IPv4 MANET. Binding registration. When the mobile node communicates with the home agent version 6, the binding registration is initiated. In this architecture, the IPv6 mobile node A from IPv6 MANET wants to roam into IPv4 MANET. So it sends A dash, that is mobile node version 6 in IPv4 manner, sends leader solicitation request to the leader node B1. Then A dash receives the IPv4 leader address solicitation reply from the leader node B1. In this registration, B1 sends the mobile node version 6 MAC address and IPv6 address in IPv4 network, and a home agent version 6 address of mobile node version 6 for COA registration. IPv6 for COA registration. IPv6 can send its connect binding update registration bind registration to the home agent version 6 without the need of foreign agent, so that A dash in IPv4 MANET to register its of address directly to the home agent version 6. While receiving the binding update registration from A dash, home agent version 6 sends binding acknowledgement message to A dash. Router discovery. In this router discovery, A dash sends route request to B1, then it checks the destination node is already received the packet with the source sequence. If B1 is already received the packet, then it discard the packet. Otherwise, it sends the packet to the destination. Redirection of the packet. The corresponding node V6 communicate with the mobile node version 6, then with the home agent version 6 for obtaining of address. The corresponding node V6 extracts 17 to 48 bit portions of the COA, then it converts hexadecimal into decimal notation for communication. So the summary of the contribution one, the proposed system guarantee for IPv6 address generation in IPv4 manner. The V64 gateway translator generates the address for communication in manner. Corresponding version 6 transfer the packets through home agent version 6. Contribution to IPv4 mobility architecture in IPv6 manner. Here, IPv4 mobile node B with a 32-bit address in IPv6 network or IPv4 MANET. A1 is the leader node in IPv6 MANET. IPv4 mobile node B dash, while roaming into IPv4 MANET, it's to be identified with a 128-bit address. V46 enabled gateway translator is installed to all the neighbor nodes through A1. So let us consider this is an overall architecture for IPv4 mobile node in IPv6 manner. Let us consider that the IPv4 mobile node B from IPv4 manner wants to roam into IPv6 manner is called it as a B dash. The IPv4 enabled gateway translator is installed automatically to A1 and provide the global connectivity. This architecture is to be achieved by the following functionalities such as leader node election, tree construction procedure, neighbor node response, addressing architecture, enabled gateway translator, binding registration, COI registration, router discovery, and redirection of the packet. Leader node election. So here the IPv6 mobile node initiate the communication. A dash enter into the manner and it check if A dash is out of the network range. If A dash is within a network, then it will be a leader node. If not, the leader node which has joined next to A1 in the network will become the next to leader node. MANET construction tree procedure. So here the new node B dash enter into the IPv6 MANET. B dash sends concessions request sends to the leader node. Check whether B dash receives the response within a time. If it is receives the response time within a time, A1 receives address from the address pool. If not, B dash again sends the concessions request. The selected address will be checked by the DAD. The DAD check this DAD status. If DAD replace exists, then B dash selects another address. Otherwise, A1 waits for selecting another address. B dash sends acknowledgement to the leader node regarding the newly selected address. B dash sends and receives the message using the new address. V46 MANET neighbor node response. So this procedure is used to respond the address for the new node B dash. If B dash received constructions response acknowledgement, then it is appended into the tree of the IPv6 MANET. B dash sends construction response request to A1 for joining into the tree construction. A1 received construction response request from B dash and A1 checks checks its status as to whether it is a neighbor node or not. If B dash is within a region, then A1 check the status and to accommodate one more child as a neighbor node. Otherwise, discard the node. IPv4 addressing architecture in IPv4 manner. According to the zero configuration work group defines dynamic auto configuration about a host can automatically configure an IPv4 address for communication with other nodes in the same link so that the IPv4 addressing we used first 8-bit as a format prefix of or 64-bit is used in the manet. Then B-4 then B dash receives for its request to the IPv6 leader solicitation message where it will be in the hexadecimal and it will convert in the decimal format and it assigned to 9 to 24-bit position of the host data that is used to identify that the host is being from IPv6 network. Then the 25 to 32 bit may be assigned the number from 0 to 25. Then this 32 bit address IPv4 address generated for the IPv4 mobile node in IPv6 network. V4 enabled gateway translator. V4 gateway translator is installed automatically to all the mobile nodes in mannered boundary region. The V4.6 gateway table generates new IPv6 address for IPv4 address. It stores the V dash of COA. Then the home agent version 4 address be generated here as a temporary address. Binding registration, the IPv4 mobile node B from IPv4 manet wants to roam into IPv6 manet, call it as B dash. The IPv4 enabled gateway translator is installed automatically to the A1 and to provide global connectivity. B dash sends address solicitation request for acquiring new care of address. The A1 sends the address solicitation reply for B dash. Upon receiving B dash, the binding update message from mobile node version 4, home agent version 4 sends back a message to B dash. Then B dash sends IPv4 binding update registration to the home agent version 4. COA registration. In this registration, the B dash sends address solicitation request to the leader node A1. Then B dash receives solicitation reply from the leader node within a time. The binding update registration and binding update acknowledgement are received from the corresponding node. The generated COA address on the generated CO address of a B dash is established the communication with home agent by request and reply of care of address. 46 M46 router discovery. Here B dash sends route request to A1 and it checks the destination node is already received the packet within a source. If A1 is already received the packet, then it discard the packet. Otherwise, it send the packet. Redirection of the packet. The newly generated mobile 46 address is registered as care of address in the foreign agent of a B dash. Home agent version 4 checks for COA of B dash. Home agent version 4 identifies care of address of B dash whether it is currently in IPv6 manet and according to the next 16-bit value that is from 9th to 24th bit, home agent version 4 forwards CM corresponding node version 4 packets to the current network environment. From this, the proposed system, this IPv4 mobility architecture in IPv6 manner guarantees for IPv4 address generation in IPv6 manner. V6 enabled gate V46 gateway translator generates the address for communication in manet. B dash transfer the packets to home agent version 4, correspond node version 4, and correspond node version 6. Design methodology. In order to achieve this architecture, there are various interfaces are designed for IPv6 mobile node in IPv4 manner, IPv4 mobile node in IPv6 manner. The interfaces are 643 concession, 64 managed neighbor node response, addressing architecture, gateway translator, binding update acknowledgement, COA registration in IPv4 manner, router discovery, redirection of the packets. According to the interfaces designed in IPv4 manner, the mobile node version 463 construction in IPv4 manner, Managed neighbor node response, addressing architecture in IPv6 MANET, gateway translator in IPv6 MANET, binding update acknowledgement, COA registration in IPv6 MANET, router discovery, redirection of the packets. And this is a sample interface code, experimental setup, experimental study. So here, the experimental study will be focused in simulation environment, simulation scenario, simulation parameters, sample code from simulation. So the simulation environment, the hardware we are using Unix version 6, 10, 64 and 8 GB RAMs we use, and the graphics AMD E300 APU with the ReRAM HD graphics is used for the CPU speed, and software implementation NS2 is being implemented. This is a simulation scenario for IPv4 mobile node in IPv6 network, and this is IPv6 mobile node in IPv4 network. These are the simulation parameters. This is a sample code from simulation. Performance study.
Just a minute. Please go back to slide number 77.
Yes, sir.
Yeah, just. Okay. Okay, carry on, please.
The performance study. The performance of this simulation is analyzed by using 8 metrics: byte by rate analysis, maximum payload overhead data rate, throughput analysis, network analysis, response time analysis, end-to-end, packet delivery ratio, and handover latency. The byte by rate analysis it refers as the failure of packets from source to reach its destination. So here the byte per rate analysis is increased from 6 to 4 and is decreased from 4 to 6. The maximum payload overhead data rate analysis, it shows that it is increased from 6 to 4 mobile node, and it is decreased for 4 to 6 mobile node. Throughput analysis. The throughput analysis is used to analyze the average data rate of successful packet sent to the destination. So here the throughput is high from 6 to 4 and throughput is low from 4 to 6. Network latency analysis. So here the time taken to get the data to reach its destination over the network is called latency. So in the network latency, the 6 to 4 has highest delay and 4 to 6 has lowest delay. Response time. Response time is used to analyze the affects the processing time of the leader node and its delay of the destination mobile node. So it is decreased for 6 to 4 mobile node and it's increased for 4 to 6 mobile node. End-to-end delay analysis. End-to-end delay analysis is calculated as an aggregate of all the delays in the path. So here, from this simulations, we received that IPv6 to IPv4 end-to-end delay is 6.66 per second, and 4 to 6 is 11.66 per second. Packet delivery ratio. The packet delivery ratio is the ratio of successfully received packets from total number of sent packets. So here the packet delivery ratio is 93.75 and 4 to 6 is 75%. Handover latency. The handover latency is the time to get an IP address of a new foreign agent and since registering it into home agent is called handover latency. So here in the 4 to 6 handover latency is high and 6 to 4 the handover latency is low. Conclusion. So here new and novel architectures are to be. This is my architecture is new and novel, and there is no similar work exists. It's used in the emergency environment such as natural disasters like earthquakes, tsunamis, floods, artificial disasters such as war and terrorism. It permits roaming of IPv6 mobile node in IPv4 MANET, permit roaming of IPv4 mobile node in IPv6 MANET. The leader node acts as a router and provides services to the mobile node in MANET. The possible enhancements in the proposed research work is that is extended by adding secure communication and encouraged to consider quality of service, different organization with key management. And publications. So the first paper is published in the Scopus Index Journal, and second paper, Technical Insight of MANET, is published in UGC Catalyst, and third paper, Address Configuration Mechanism, a pragmatic survey, published in UGC Catalyst. The fourth paper, a literature survey on transition mechanism in IPv4 and IPv6 MANET, is published in IEEE Proceedings. The fifth paper, IPv6 Mobility Architecture and IPv4 Manet published in IEEE Proceedings. The sixth paper, IPv4 Mobility Architecture and IPv6 Manet published in Scopus Index Journal. And the last paper, Performance Study of IPv6 and IPv4 Manet Architecture, is to be published in the Springer Proceedings. So these are my references. Thank you. Thank you, everyone.
So, yes, Manimoji,
Yes, sir.
very good presentation.
Thank you, sir.
And there are a few questions which I had asked you.
Yes, sir.
One was about the security vulnerabilities.
Yes, sir.
So, how will you address them?
Actually, sir, in our proposed architecture, we didn't focus on security vulnerabilities. In
Yes.
future, we can extend the security
Right.
vulnerabilities in the perspective of to communicate with two manners or to be communicated and what happen between two manners and what other security concerns will be considered. For example, man in the middle attack and then snooping attack and then message transfer like that. So in a
Right.
future, we will append it into our proposed architecture.
Right. My second question was answered in the presentation itself. And what about the third? That is, how will your results change if the number of nodes is increased, say to 100?
Yes, sir. Actually, this is a proposed in our proposed architecture. We used only 8 bits in order to simulate the intermobility architectures. So, if we are increasing into 100 nodes, definitely the congestions may be increased, packet loss as well as packet delivery also be increased. So, in future we should incorporate we should solve all those problems.
Okay. Have you corrected the figure number 6.7?
Yes, sir, corrected, sir.
Okay. So that was all from my side. These many questions were there. From the audience, if anybody wants to ask any question. Anyone from the audience?
Ma'am,
Yes,
good
sir.
morning.
Good
This is
morning, sir.
Arun from Dubai.
Yes, sir.
I have one question. I can see that from the entire architecture, if I understood properly, you are going from IPv4 network to IPv6 network
Yes,
with
sir.
a MANET in place.
Yes,
The
sir.
question is like when you take a simulation list, how many times you run and then took the result?
Actually, nearly 50 times we simulate the architecture in order to get the result.
So if I understood properly, all the 50, it almost
No,
consistent in
sir.
the result, right?
No, sir. Each and every time the results may be varied because the mobile nodes can move randomly. Sometimes the mobile node may or may not want to into the network, so that
Okay, ma'am.
the packet
Okay.
size also
Thank you.
be
Thank you.
changed. Okay, sir. Thank you, sir.
Right. Anybody else?
Hello, madam.
Yes, sir.
Is my voice audible? I am Dr. Mani from Nehru Memorial College,
Yes,
Chanambati.
sir. Yes, sir.
Okay, so first of all, I congratulate the candidate as well as the guide for selecting such a wonderful topic. And moreover, your presentation is very, very, very good. Okay, right.
Thank you, sir.
And I have some clarification.
Yes, sir.
Clarification is, how do you select the leader node?
Yes, sir.
How do you select the leader node? Is there any
Yes, sir.
criteria?
Yes, sir. Yes, sir. In order to find the leader node, we use temporarily ordered allocation algorithm in order to find the leader node.
Okay,
So
but you didn't
yes,
mention
sir.
any place.
Okay, sir.
Okay, that is one thing.
Yes,
Then
sir.
another thing, how can you see a particular node is adjacent to the other node?
Yes, sir. Each and every node in our MANET maintains the routing table. In that routing table, it should maintain along with the hop count, whether it is a leader node or whether it is a neighbor node like that.
No, I am talking about the adjacency. Adjacent node.
It's a neighbor
How
node.
can you say the node X is adjacent to Y?
Yes, sir. Yes, sir. Here, sir. One second, sir. Initially, and it checks whether there is a whether that is any outgoing link or not. If it is a node in a particular region, the automatically next node will want to join into the new cluster group. Based on the cluster, we have to identify the adjacency pairs.
Suppose you have more than one out degree.
Sir?
One node has only one out degree, other node has more than one out degree. Then how can you say which one is the adjacency?
Sir,
So based
for
on the
that,
degree, you are identifying the particular node adjacency or not.
yes, sir, for that we have to maintain the tree construction procedure. See here, sir. For that, we have to maintain the tree construction procedure.
Okay. So based on the degree, can you say that based on the degree of the
Actually,
based on the degree of the node. Degree is nothing but the number of nodes connected to the
yes,
particular
sir,
node.
yes, sir, yes, sir. For
So
that,
based
we
on
have to, for that, in the simulation environment, we have to use the directional as a parameter.
okay.
Omnidirection as one of the parameter in the simulation environment in order to identify these nodes
Normally the
adjacency.
people are using on the basis of the degree of the node, the particular node is adjacent.
Sir?
For example, one node the degree is equal to 1, other node the degree is equal to 2. Okay, so if it is a case, then adjacency node is the thing. Now this figure that is 44.
Yes, sir.
You figure
Yes, sir.
44.
Yes, sir.
So you are saying that this is a tree.
Yes, sir.
But here there is a circuit. There is a circuit.
Okay.
Say for example, you take the
So, sir, in MANET, all the nodes are to be connected together.
So connected graph.
Yes, sir.
The tree is nothing but it is a connected graph.
Yes, sir. It is a hierarchical format. In a MANET, all the nodes are to be together. If any one of the node leaves from the network, the other nodes will act as a leader and provide the services to the neighbor node.
But it doesn't call to the tree. As per the definition is concerned, the tree is nothing but it is a connected graph with no circuit.
So, if it
Connected
is
graph with no circuit. Do you agree or not?
if it is a connected graph means the leader node will also be joined to some other node.
Say for example, so please. Say for example, you take this figure.
Yes, sir.
So min 1 to 2, then min 1.1.2, then min 1.1.21. Okay.
Yes,
Now
sir.
this min 1.1.21 is connected to 1.21. Similarly, the min 1.1.2.1 is connected to the 1.1.2. Again, it is connected to 1.2. So all are connected together. So it forms a circuit.
Yes,
It
sir.
forms a circuit.
Sir, actually, in a circuit, all the nodes are to be connected together. Here, I am going to mention this diagram. This procedure is that the leader node which is connected to the other neighbor node, that neighbor nodes are to be connected with
Then
the
if it is the
other
case,
neighbor.
man, if it is the case, you can use arrow mark. It is only one directionally. You should not use bidirectionally.
Okay, sir. Okay, sir.
So what my understanding is, this is not a tree because it is a circuit. It forms a circuit.
Okay, sir. Okay.
So better you can use the arrow diagram.
Okay, sir. Okay, sir.
So if it is arrow, then it is one way.
Okay, sir. Yes,
So
sir.
we just say it is not at all a circuit.
Okay, sir.
Okay.
Okay.
Then IPv4 and IPv6. So we are making some kind of conversion, isn't it?
Sir.
IPv6 to V4 or IPv4 to V6. So which one is higher? Then IPv6 is higher.
When compared to IPv6 to IPv4, it takes higher latency because of the address conversion.
Address
4 to 6,
conversion.
yes, sir. When you consider the 4 to 6, the address conversion takes much latency.
Okay, IPv6 is 128 bit. Am I correct?
Yes, sir. Yes, correct, sir.
IPv4 is 64 bit.
Yes, sir.
So since the 126 bit is higher, then why we go for IPv4?
Sir, no, sir. In IPv4 manner, normally in IPv4 network, it supports only the IPv4 address. It only supports the decimal format. In
Okay.
IPv6, the address will be identified with the hexadecimal format. So
Hexadecimal
IPv6
and decimal. Ma'am, hexadecimal and decimal. Only for our convenience, we are using hexadecimal and decimal.
sir, no sir. In IPv4 network, it should be identified. The IP address should be identified with the decimal number. Decimal format
Professor
only
Mani,
is supported.
Yes,
uh,
yes. Ma'am,
Mani,
Yes.
ma'am,
yes,
this is Dr. Gnana Jayanti. Actually, the IPv4 addressing architecture is designed in, its representation is designed in such a way that it is in decimal format. IPv6 is designed in such a way that it is in hexadecimal format.
that is the only difference.
Uh,
So, okay, ma'am,
Standard.
ma'am, you go to the 80 slide in the slide number 80. The simulation result, right?
Yes, sir.
See, in the last column, all the values are same.
Yes, sir.
The
Yes,
packet
sir.
size is 512, then 1024, then IPv4 to IPv6, all the values are same.
Yes,
Right?
sir. When we
Then what is
simulate
the
this
necessity?
one, yes,
Yes?
sir. So actually, byte per rate implies that the number of bytes per second. The byte per
Yes.
rate would be referred as byte per second. So from our simulation, the the conversions the byte is being transferred per second. 512 is 0.5. 1024 is being the two formats like a 512 and then 512. So that the results will be like that.
So it doesn't mean that the packet size doesn't play any role at all. Am I correct? Because for all the cases, you are getting the same result, 0.5 byte per second. 0.5.
According to my simulations, I received this output, sir. This result.
Is it justifiable, ma'am? Okay, but simulation result I do agree. Is it justifiable? But what is the necessity for increasing the packet size?
Sir, we couldn't predict the packet size. In a network, we couldn't predict the packet size. So that there
Okay.
is a simulation. We considered all those packet for the simulation, sir.
Okay, I agree. But
Yes,
the
sir.
thing is, then even if you increase the packet size, then you are getting the same result.
Yes, sir.
Dr. Mani, may I interrupt?
Yes,
Dr. Mani, yes.
yes.
She may explore why, yeah, she may explore later, okay?
Okay, okay. So
Why it
thank
is
you.
constant, why it is constant, okay?
Okay,
Mani
thank
Master?
you.
Yes, sir.
Okay.
Thank you so much, madam. Thank
Thank
you
you,
for
sir.
your nice
Thank you, sir.
presentation. Okay,
Thank you,
okay.
sir. Thank you, sir.
Thank you, Dr. Mani, thank you.
Okay.
Good afternoon, Manimuri Madam. Hearty wishes for your wonderful presentation.
Thank you, sir.
Uh, I have small clarification.
Yes, sir.
Actually, you introduced T gateway. So already in the
Yes.
literature, so many works are carried out in this
Yes,
field.
sir. Yes, sir.
What is the unique feature or what is the special feature of your gateway? What way it is going to
Yes,
improve
sir.
the existing architecture?
Yes, sir. Yes, sir. 1 second, sir. Actually, in a already existing mobility only supports us for gateway, translator, binding, update registrations like that. But my architecture will support leader node election, pre-concession procedure, neighbor node response, as well as binding registration, COI registration, router discrete, and redirection of the packets. So when you
Okay, okay.
compare to the already existing network, it's only supported for IPv4 in IPv6 network and IPv6 in IPv4 network. It doesn't provide the configuration mechanisms for IPv4 mobile node in IPv6 MANET and IPv4 mobile node in IPv6 mobile node IPv4 MANET. So,
Okay.
and
So
also the yes,
in the neighborhood response, what is the advantage? The neighborhood response. What's the
yes.
advantage of your model?
So if a neighbor node response is that initially consider that the only one node is being in mannered communication. So that is be acted as a leader node. After another node enter into the mannered, but that node wants to make a communications in the network environment so that it identify whether it is any neighbor node is there in order to join with the leader node and get services from the leader node.
Okay.
Okay.
How many neighbor nodes can be applied either in this model, proposed model?
Actually, I consider the eight mobile nodes, sir. So we can any number of nodes we can make a communication as a neighbor node because if node can willing to join in the manet, some of the nodes and some of the nodes are not willing to join into the manet. So it depends upon the nodes communication. The neighbor node to be joined into the manet communication.
Okay. Okay.
Okay. Very good, madam. Very good. Hearty wishes to candidate as well as to madam. Very good,
Thank you,
madam.
sir.
Thank you.
Thank you,
Madam
sir.
Manimuli, madam.
Yes, sir.
Okay, very nice presentation.
Thank you, sir.
The difference between the IPv6 and IPv4,
Yes, sir.
and also then this is some pages are small corrections.
Okay,
Okay,
sir.
already the money Dr. Mani can already said
Okay, sir.
the packet size is increasing.
Okay, sir.
The byte per second is the same 0.5.
Yes, sir.
A small it is in typographical error.
Okay,
Okay, please
sir.
rectify in future.
Okay, sir.
Research is not ending. Okay, it is in
Okay.
recycling process. Okay,
Okay, sir.
after you guided to some students, you learn something. Okay, anyway, your presentation is very nice. Okay,
Thank you, sir.
sir, Dr. Sadish Chandra sir, professor,
Yes, sir.
you maybe declare the Viva wise
Yes, sir.
reports.
Yes, sir.
Okay.
So first of all, I convey my New Year greetings to all present here. Presentation of the thesis was just awesome, and the scholar answered the queries patiently. And the scholar, through her publications and the thesis, seamless IP version 6 oblique IP version 4 intermobility architecture between IPv6 and V4 MANETs, has proved that architecture proposed by her is competent enough for the required intermobility between the two versions of IP. Based on the successful defense of the thesis, I recommend the award of Doctor of Philosophy to Miss S. Manimoji. Henceforth, she may carry the title of Doctor. My heartiest congratulations to Dr. S. Manimoji. My congratulations to her supervisor, Dr. J. Gyanam Jayanti, and my regards and congratulations to Dr. Vadival also for conducting the presentations so smoothly. Thank you, sir.
Okay, thank you, sir. Thank you very much.
Thank you, sir.
Thank you. So may I sign off, sir?
What, sir?
May I sign off now?
Yeah, you maybe leave the meeting. Madam,
Okay.
please, what of thanks, please, one second, sir.
Okay.
Um, Thank you very much, sir. I personally thank Dr. Satish Tantra, the external examiner, and Dr. E. Vadivel, sir, Bharatiyar University nominee, for your kind participation and encouragements, and also for your exemplary conduct of organizing this public Viva examination. Thank you, sirs. Thank you very much.
Thank you,
I
madam.
thank.
Thank you.
Thank you.
Dr. Manimuli, thank you.
Thank you, sir.
Thank you. I leave the meeting, sir. Okay, thank you, sir.
Okay.
Okay,
Thank
okay,
you.
okay, sir. Thank you, sir. I thank all the professors and research scholars who are present in this PhD public Viva examination. I invite Dr. S. Manimali to propose vote of thanks.
I turn to God with heartfelt gratitude for flooding my life with the memories of His love that has been shaping me all along to what I am today through various distinct personalities and life situations. I am thankful to the Honorable Vice Chancellor, Bharatiyar University, for providing the necessary authorization to carry out my research work. I thank the respected registrar, Bharatiyar University, for permitting me to go ahead with this research. I place on record my sincere gratitude to my guide, Dr. J. Jnana Jayanti, Assistant Professor, PG and Research Department of Computer Science, Raja Safoji College, Tanjavur, for her motivation, knowledge sharing, and inventive ideas. Her guidance helped me in all the times of research and writing of this thesis. I extend my sincere gratitude to the following members of the Department of Computer Science, Bharatiyar University, for their helpful suggestions and constant encouragement. I extend my sincere gratitude to the Dean, HOD, and faculty members of the Department of Computer Science and Applications, Periyar Maniva Institute of Science and Technology, for their helpful suggestions and constant encouragement. I also express my deepest thanks to Dr. N. Arun Raj, Senior Architect, and Dr. Christy Sujata, Assistant Professor, Department of Software Engineering, PMST, Sister Amali Pushpam, Vice Principal, Bonsakas College, Tindukal, and Ms. Rojo for their constant support, motivation all the way through this period of my research work. It is with great joy that I thank my husband, Mr. S. Vijayarajan, beloved parents, Mr. K. Subramanian and Mrs. Selanjiam, in-laws, Mr. P. M. Silvaraj and Mrs. S. Vijayalakshmi, my kids, V. Kaviraj and V. Kirtikraj, my relatives, friends, and well-wishers for their support, encouragement, prayers during my research. Thank you all.
Thank you, madam.
Sir, thank you, sir.
Thank you.
Sir,
Thank
I
you,
give
sir.
the meeting, madam.
Ah, okay, sir.
Okay,
Thank
thank
you,
you.
sir. Thank you very much, sir.
Scholars and guide, and also the all the participants, madam.
Okay, sir.
Okay.